Hey guys, it's Vince. Today in this video, we are going to be taking a look at yet another content creator who just started their YouTube channel and of course is working on their CNC controller and wants to hand down his knowledge to his audience. Once again, I'll let you be the judge as we go through this system build and analyze it if this is something he should be doing. Let's jump right in.
I took the fan off. It was basically set to blow air this way. I did verify that the power supplies are pushing air, the fans are exhausting out there. So I'm going to flip the fan over so that it's exhausting, and then I'm moving the wire over to here instead of here because I didn't want it to have any electrical interference with the USB connector there.
Alright guys, so the content creator opens up the video by explaining where he's going to relocate his fan, and he's going to take its wiring, which is AC, and move it away from the DC wiring going to his USB motion controller, which just so happens to be a UC100 from CNC Drive. Here's the issue. Many of you already know my feelings if you've watched any of my videos on Universal Serial Bus, also known as USB. Universal Serial Bus is completely unstable for CNC motion controllers. Now, many of you may argue that point. Let me put this on screen to once again alleviate any confusion. Balzis, lead engineer over at CNC Drive, who actually manufactures the UC100, this is a direct email conversation between him and I regarding the UC100 and random disconnect issues dealing with voltage spikes, grounding issues, EMI, the list goes on and on. This is why I'm telling you guys all the details count. I say it in all my videos. These content creators, once they get a license to create content, so to speak, by opening up a channel, they can do whatever they'd like with that channel at this point, to some degree. The issue is when they start doing DIY projects like this, of course, we know that their audience is subjected to whatever components this gentleman is using, and if they don't know any better, then they may mimic exactly what this gentleman is doing, and in which case shoot themselves in the foot. So once again, check out the email right here, read it carefully, and I hope this gentleman reads it carefully, and then maybe he'll decide to once again look at the investment he's made, and this way he can get started on the right foot just by eliminating USB. The other case that we brought up is about mitigating EMI by just separating distance of AC and DC cabling. You should be using in best practice one of two EMI mitigation practices when building your controller. Either utilizing double shielded cable or ferrites, or the combination of both. If you use double shielded cable, there's more labor involved because you do have to allocate shield drains, and all of your grounds will have to go to a ground bus within a motion controller, and that's bottom line. If you're doing an IDS system like he is, an individual drive system, you're looking at a lot more time and labor, and that's why I stay with the G540, and we'll be working over to the SMCU systems that we're working on right now, because an integrated drive system is much easier for any novice, let alone an advanced user who wants to hit the ground running with a system that's already pre-done. When you start building individual drive systems, you've got a lot more wiring, a lot more time, and a lot more headache. And that's where more knowledge must be prevalent. We also then have to utilize ferrites if we're not going to use double shielded cable once again, and you want to mitigate all that hassle of dealing with all those ground drains. You can do the ferrites if they're once again utilized on short leads. With inside an electrical enclosure, that is fine because most leads are going to be within 12 to 13 inches, and that's perfect. When you start doing longer cable runs, that's where you have to really be careful, because for some reason guys think that ferrites are going to work magic, going 13, 14 feet, and it just doesn't happen. They're much better utilized under small lengths.
I just wanted to keep the AC stuff away from over here. I've also gone ahead and grabbed some 12 gauge wire. It's got 4 conductors in it. The only thing that requires me to run this neutral is the fan. Everything else is good for 220 volts. So because of the cooling fan, it not being 220 volts, I'm going to go ahead and run a neutral in here.
Okay, so this question actually comes up quite a bit, and it's interesting because I really haven't discussed this too much in previous videos. And that is when we're dealing with gauge of wiring and we're dealing with amps, guys tend to go off the deep end. They always want to overbuild in safety. And what's really interesting is they usually end up paying more to try to do that than they have to. This individual actually went with 12 gauge power cord, and he really didn't need to do that. 16 gauge is going to be optimal for most AC to DC powered systems. Now, there are a few guys that are running three-phase systems, or if they're running AC servos, that may require a larger power cable. But once again, how many of these systems are out there? Far and few in between. What we're seeing here, he did not need 12 gauge cable. The other thing to keep in mind is this. Naturally, the thicker the gauge cable you use, the less flexibility you have. Not so much a deterrent when we're dealing with a power cord for a system. However, when we start dealing with cables that are running within a cable chain, that changes dynamic. So that theory of always going bigger and heavier to give yourself a line of safety, that makes sense, but it also affects your budget, and it could also affect flexibility of those cables. So keep that in mind all the time. The next variable is that while amperage is directly controlled typically by the gauge of wire, it's not the only variable that really makes up how much amperage a cable can take. Let me explain. I'm going to put a diagram on the screen that came from the engineer's toolbox. And I put this in all my spindle cables ads because, again, it helps you guys understand how these cables are rated for certain amounts of amps. And what you'll notice is different temperature ratings on the casing allows the cable of the same gauge to handle higher amps. Why is that? More amperage means more heat. That means the cable must be able to withstand that level of heat to be rated at a different temperature, and therefore it can handle more amperage, even if it's the same gauge. So what does that mean to you, the end user? Well, it means that, yes, I can usually use a smaller cable and go with a baseline of the amps that it's rated to. I get a lot of guys that want to do that. Well, then I can run 18 gauge for spindle cable. Okay, how long is the cable? Oh, the cable's going to be 25 feet. Well, then you really don't want to use 18 gauge, but it can handle the amps. Well, I'm sure it can, but here's the issue you're not thinking about. What about voltage drop-off? The thinner the gauge leads, you're going to have voltage drop-off as we keep going longer and longer away from the source. These are variables that will affect your hardware and things to think about as you're building your system. And that's what you pay me for. When you say, hey, Vin, I don't know this, I want you to just take the guesswork out, that's what I'm here to do. And that's why I'm telling you, when you start looking at someone who's responsible saying, hey, I'll put my money where my mouth is that I'm investing in my components. I then sell you the components that I invest in. And then I'm saying that my channel will back you in the sense of how to use these components optimally to have a stable production robot. The question I ask all of you, and especially the trolls, do these content creators do that? Can they do that? You guys be the judge.
But from here on in, I basically don't have to worry about the current as much, so I can get away with using 14 gauge, and in some cases, I'll be using 16 gauge.
Here he talks about not worrying about the current as much. Once again, going from 14 gauge to 16 gauge. He could have used 16 gauge all along and he would have been just fine. One other point I want to make that is something I've seen in many systems. You guys will review some of my videos and see this. There are a lot of content creators that use 2 power supplies to power their drives. This is not best practice. Why? Because 2 power supplies generate more EMI than a single power supply that supplies enough amps to the amount of drives you're using. This is best practice. It also saves you money on purchasing a larger electronics enclosure because you're not housing all of those extra components. China will bundle as many power supplies as it takes because in their eyes it's faster for them to do that than to do the calculation of how many amps they actually require to power the drives that they're giving you. This is fact. If you, the end user, go to purchase overseas and you don't know how to communicate with them or they don't know how to communicate with you and you can't actually dictate to them, hey, I want one single power supply, these are the issues you run into. Do not let content creators act like this is best practice. Do not let them pretend that they understand this principle, because obviously they don't. And that's what I bring up in these videos. Many of you understand that. The obvious mistakes here are mistakes that are generated by a general novice. These are not generated because somebody understands not just electricity, but electronics and how these electronics perform when built at the capacity that these people are doing.
Alright, so I got some wires stuffed in here, and I basically just want to go over what's going on with the way I've got the 5-volt feeding the motor drivers and then getting the negative from the communication board. If you look here and you follow these red wires, this is coming from the 5-volt positive of this. Then I've got it jumpered over, and on the other side we've got pulse positive and direction positive. So those two are getting 5 volts directly from the supply, and then they're getting the negative from this board. So when this board sends out its signal, it's sending out basically a signal to ground.
Well, this is really interesting because now he's explaining about his breakout board splitting the ground going to the drives. So I want you guys to think about that for a minute. Think about what you just heard. How logical is that? Have you ever heard that before? It doesn't work that way. Number one, V negative on your power supply, and I've discussed this in previous videos, I've discussed it with potential clients, is not a ground. It is a common, and he did correct himself in the video. The unfortunate side is that when end users of any type, novice, advanced, hear that word being interchanged with ground and common, then they automatically assume that V negative on their power supply typically is a ground, and that's not the case. So when we talk about ground with CNC electronics, we should be talking about the ground bus of the system, or a ground terminal, and a ground terminal that takes an earth ground. That's it. We shouldn't be talking about V negative being a ground. It is not. And that's where this terminology will carry over and destroy novices, because they get confused and they interchange the terms, and then we have problems. That's why I tell you how critical it is with these details. Some guy going over his system with a little screwdriver and claiming that he knows from one wire to the next, that is not defining knowledge. Defining knowledge is the details that he's actually put into the system with research to make sure that the system is going to perform as designed, not just turn on. Once again, connecting wires is simply following a wiring pattern, aka wiring diagram. If we can do that, and that's all we can do, then you are not going to be considered knowledgeable in this field if you can't understand the details that make connecting everything in that wiring diagram stable. Think about what I just said. This is how critical this is. If we look here at his drives, once again, you can see he's got a terminal block there that's actually accepting 2 leads, and there's 16 gauge leads. So I want you guys to think about that. What terminal block on a driver is willing to accept 2 leads? They're not designed for it. And I've said this before in previous videos. Once again, lack of end user knowledge leads to poor performance. And it's fact. Now, is that going to affect his system? It's certainly going to affect those drives, because, again, that terminal block is only designed for one individual lead. Now, how do you attach 2 leads to a single point on a terminal block? Very simple. You'll use a dual position for rule. I'll put it up on screen here. I've done this in previous videos. And this is common when these guys use IDS drives, individual drive systems. They typically will wire their drives using jumper to jumper, and they don't understand or don't care to actually put the time in to do it right. And that's where we have problems. It just becomes so interesting to me. It's kind of like a contractor who knows he's putting up drywall over a shoddy electrician's job, and they just put it up and they figure, well, no one will ever see it. When they go on YouTube and open up the enclosure on these systems, that's when everything becomes apparent. And you can't hide your work. So it's baffling to me, and it should be just as baffling to all of you, why anyone would be so excited to show you their work, and they're essentially showing you, hey, I don't know what the hell I'm doing for myself, let alone should I be presenting it to you.
Some other connectors there. And then I have already gone ahead and put my twist lock connector in here. So that's going to be where the the mill actually plugs in for the main motor. Other than that, my fan's hooked up, everything's about done. All I've got left to do is solder up this connector and connect it up, connect up my emergency stop stuff, and this box is ready to start configuring to the computer.
Well, the content creator feels all he has to do is configure this to his PC, and he's completed the construction on this controller. The issue is this. This is far from done. First and foremost, let's talk about safety and talk about problems with your insurance company paying you if all details aren't covered for safety. Now, what am I talking about? Look at his GX16 motor connectors that are attached to his drives. I'll zoom in so you can look at them. You can see there is no heat shrink applied to any of those solder terminals. If that is done, you can rest assured, if God forbid this enclosure encounters a fire and this content creator is in an asset that's protected by insurance, namely his shop or his home or wherever he may be, they're going to scrutinize anything that they can determine caused that fire. If, of course, they determine that heat shrink was not applied to insulate properly, they are going to say, no, sir, we're not going to pay you. Me explaining this to you just saved you possibly thousands of dollars. This is fact. I hope you all do your own research on it. The question is, where do we let this continue? Let's look at the remaining portion of the controller. We can see there's no ground bus installed. We do see he has a terminal block allocated to some ground leads going to his power supplies, but being he has no built-in EMI mitigation at all for the system and he is using USB, we can see he's not using EMI ferrites for passive filtration, and we can see he's not using double shielded cable with any shield drains allocated to a ground bus, which would indicate once again that the controller itself is not grounded using that start point ground method. So again, we know this is best practice from previous videos, but we can see here we've got some severe issues. So I'm asking all of you, do you think he's done? Because he does. He thinks he's all set to go with this, which should tell all of you once again, these content creators, unfortunately, have one interest in mind, and that is to get paid by AdSense for content that they create. They are not here to be your friend, to help you succeed, because if that was the case, you have to ask yourself, then why would you put information out that is blatantly wrong in the sense of best practice for me to get the desired results of what I'm dealing with my CNC production robot? Because truth be told, if that was the case and they really wanted you to succeed, there would be some sense of responsibility towards that. So when you think of how much you end up paying a professional like myself, that is what you should be asking yourself. When he's getting paid, maybe it's because he's taking on the responsibility of saying, hey, I have to help this person succeed.
All right, so before we get started, I just want to show you that these little pins here are set in plastic. So you don't want to set your soldering iron to these for very long. It's really easy to melt them and then they just push right on through. So what I'm going to do is I'm going to go ahead and get the solder on each of the wires and then basically have a little ball of solder at the end so that I can just touch it to it, put my heat on there
We'll get
for
to see
a
if you
little
use some
bit
flux.
and let the solder soak into this before it gets too hot. So get started on that. Alright, well, not my proudest work, but must have melted a little bit of the green. Get some electrical tape around that.
Well, the content creator comes forward as an instructor explaining to his audience what his process is going to be, applying solder to the leads, that's called tinning, and then of course joining those leads to the terminals on the GX16 connector he's working with. Unfortunately, as many others before him in the content creator world, he's failed because he didn't explain using flux or show flux at all being used. No, he decides to explain to the audience that you have to be careful on these connectors because you can melt or set loose one of the terminals if you apply too much heat. Well, here's the thing. You would never worry about applying too much heat if you're using flux, because flux is going to allow the solder to flow properly once that heat is applied. Once again, defining incompetence. Look, the fact of the matter is these content creators do no research, number one, and number two, they lack the budget required to buy the right tools to do the job correctly. That should tell you something. You don't want to be that guy. And that's what I tell you guys all the time. We're seeing that projection of I'm trying to show you what I do. Unfortunately, what he does is wrong. So much so that when he actually destroys a casing on one of the leads going to the GX16 connector, he's saying to use electrical tape. I'll go back to another previous portion of the video and once again direct your attention to what do you think an insurance company investigator would say, God forbid there's a failure in that enclosure, if they find electrical tape. What do you think they're going to say? They're going to look at that and know that's not professional and know that's a wing job, and that's where you run into problems. You don't want to cut corners where there's jobs that need to be done correctly, and we're talking about a lead that has damaged casing. Immediately, what he should have did is said, hey, I'm going to stop right here. I'll replace that lead. Or do a direct reflection on one's abilities and say, hey, maybe I'm doing this wrong. Maybe there's a better way to do it. We saw him actually jig up the connector in the vise vertically. That really makes no sense because your leads are going to go in horizontally. If you ever watch any of my soldering videos, you'll realize all of my GX16 connectors, any connector, I solder in a horizontal fashion. These guys that like to articulate the GX16 connector or whatever they're working on, they don't even think about logically how they're going to apply that solder to that lead. Because if we apply it in a manner that it's going to be mounted in your enclosure, it's much easier to work with. Think about what I'm saying. That's how fast this content is produced. There's no thought process. It's simply, I want to get this done to get Google to pay me.
But good enough, it is going to work. Now to get that through the hole. And if your solder connections were no good, just go ahead and redo them. Alright, so no need on the Band-Aid there because I went ahead and resoldered that connector on, got it connected in.
That's the best choice he's made so far we've seen in the video.
Just one thing I didn't go over before is all these enable pins I am not using. If you don't connect them, its default setting is enabled. If I end up deciding to hook those up later, it's pretty simple. It's just on-off based on pin outputs. You can daisy chain them together or set them up individually.
It's really interesting that the content creator is now discussing using daisy chaining when that's not best practice. He once again is directing his audience of using this technique. Why is daisy chaining not best practice? I've been asked that question many times. You never put in a circuitry loop a component which can fail, and if it does fail, it affects the entire circuitry loop. Think about what I just said. To make it more visual, I'm going to put it on screen in a diagram to show my novice guys exactly what daisy chaining means. And again, this defines this man's incompetence in this field. You should never ever implement daisy chaining with your system. Now, does that mean you're going to have to do more work? Yes, it does. And that's why a lot of these guys will implement that process, because then again, it saves them a lot more time. And it all goes back to me explaining that all we really want to do as a content creator in their shoes is to get that video uploaded. So once again, they get paid.
Well, here's kind of a final view of everything. I've gone ahead and hooked up this connector. I've got my 5 volts going out through it, and then coming back I've hooked up the emergency stop wire. But I'm going to go ahead and leave these two disconnected until I figure out what I'm going to do with them later. So I've made sure that both of, I don't know if they can pick this up in the camera, but both these switches are switched over for 220 volts. Everything's wired up. I still need to go write down what pin numbers I was using for everything on here. That way when I tell the computer what to communicate on it, it knows what's up. So I'm ready to hook up power to the wall here, and I think that's going to be it.
Well, once again, we have a content creator that feels that his job is done. He's ready to plug this unit into the wall and call it a day. Now I ask you, the audience, preferably both mine and his, is he done? Is this a controller you would be accepting of to own? Do you feel that what advice he's giving you in this video is correct? Do you feel that he's an authority on directing the audience to do what he's done? Because many guys out there say, well, he's not really directing anybody. Well, that's not really the case. He's telling you don't burn this pin when you're soldering, and he's directing you on how he's soldering. I mean, he's going into really great detail on this system build. And realistically, the only reason to do that is to convince others that he knows what he's doing. So what happens when people say you know what you're doing and they're in a DIY crowd? They mimic what they see. Look at CNC Zone and many of the other forums. Ask yourself, why are so many problems prevalent that are redundant? Why does that continuously happen? Why is my channel able to make these videos time and time again and have such a great list of the same problems? Many of you tell me that. It's just interesting to think about. We don't see doctors pretending to be police officers. We don't see police officers pretending to be doctors. Yet, one content creator after another can go on YouTube or another venue where they can upload a video and instantly put content out that portrays them as an authority in whatever field they want to be in. That is frightening, guys. And realistically, it's interesting when I talk to all of you, potential clients or clients, they always tell me they want the best. I want the best my money can afford. I want the best chassis, the best spindle, the best cables. Yet, without that mediocrity, no one says, hey, you know what? I'll take whatever information I can get. Think about it. If we held these people to the standard that we would expect in other areas of this genre, they wouldn't exist because you'd be filtering them out. And that's why I tell you guys, do the research that is essential to protect your money. If you've gotten anything from my videos, they will save you money on one mistake after another. Because if you think about it, there is no cheap mistakes when it comes to CNC due to the fact of how much money and time it costs you, possibly substrates. Many of the times it does include substrates. So think about these videos, and I hope you guys got something out of it. Leave a comment. I thank you all for your support. Take care.